So, when you need to find a specific piece of information in a really long, complex document, how do you actually do it? You probably don't read every single word, right? No. You use the table of contents, you check the index, you navigate the structure. But for a long time, the main AI method for this, called retrieval-augmented generation, or RAG, has been all about a purely mathematical approach. Today, we're going to dive into a new vectorless approach that lets an AI find information a lot more like a human and way less like a search engine.
All right, here's our game plan. We're going to start by looking at the limits of what we're using now. Then we'll introduce this new vectorless solution and see exactly how it works. We'll put the two side by side, and finally, we'll wrap up with the verdict on when this new approach really shines.
Okay, so to really get why a new method is so exciting, we first have to look at the cracks in the foundation of the old one. We're talking about traditional vector-based RAG, and the whole issue really boils down to one simple but super important question.
I mean, really think about that. Let's say you're searching a big technical manual for safety protocols for battery replacement. A standard vector search might just pull up every section that happens to mention safety or battery. Yeah, those sections are semantically similar, but the only one that's actually relevant is the specific one you asked for. And that little distinction, that's the core weakness of just relying on mathematical similarity.
And not one problem creates this whole domino effect of other issues. First off, you've got hard chunking, where documents just get sliced up into these random fixed-size pieces. I mean, this can literally cut a key sentence or a table right in half, completely destroying its meaning. Then the search is just a one-shot guess. There's no real multi-step thinking. It can't even follow a simple instruction like see Appendix G. And to top it all off, you need these expensive, specialized vector databases just to handle all the math.
So, if the old way has all these pretty big limitations, what's the alternative? Well, this brings us to a completely different way of thinking about how to find information, one that moves away from pure math and gets a lot closer to actual logic.
To put it simply, vectorless RAG doesn't turn your document into a massive string of numbers. Nope. Instead, it uses a large language model to actually read and understand the document structure, its chapters, sections, and pages, and then it reasons its way to the right answer.
This analogy just hits the nail on the head. Instead of brute force searching the entire book for keywords, the AI uses the table of contents to find the right chapter, then it skims that chapter's headings to find the right section. It's this targeted, logical process that's way more like how a human researcher would actually do it.
And the benefits here directly fix the problems we just talked about. The retrieval feels human-like and logical. Because it respects the document's natural layout, it completely avoids that destructive artificial chunking. The step-by-step process is also transparent, so you can actually follow the AI's train of thought. And hey, as a nice bonus, you can say goodbye to those complicated and expensive vector databases.
Okay, so we've covered the what and the why. But how does this thing actually work under the hood? Let's walk through the PageIndex workflow, which is one of the leading ways to do this vectorless approach.
The whole process really breaks down into three main stages. First, you prep the document. Second, you do the search. And third, you build the answer. Let's take a quick look at each one.
So this first step is all about mapping the terrain. The system analyzes the document, but not for keywords. It's looking for structure. It identifies all the headings, subheadings, and even the page breaks to build this hierarchical tree. You can think of the root as the whole document, the main branches are the big sections, and the leaves are just the individual pages.
And this is where the really intelligent stuff happens. You give it your query, and the LLM starts at the very top of that tree and makes a series of logical choices. It's asking itself, okay, which major section is most likely to have the answer? Then it goes to that branch and does it again. All right, now which subsection is the best fit? It just keeps going like that, moving from general to specific until it pinpoints the exact pages that it needs.
So once the system has figured out the most relevant pages, it assembles only that context. It doesn't pull in a bunch of loosely related similar chunks that might just confuse the final answer. It creates this clean, focused, and super relevant package of information and then hands it over to the LLM to generate a really precise, well-supported answer.
So now that we have a pretty good handle on both methods, let's put them side by side for a clear head-to-head comparison.
When you boil it all down, the fundamental difference is this. It's math versus logic. Vector RAG makes a mathematical best guess based on what looks similar. Vectorless RAG makes a logical deduction based on the document's structure and a chain of reasoning. One is basically a search, the other is an investigation.
And this table just lays it all out so clearly. I mean, look at the search process row. Vector RAG is just a one-step grab of the top results, while vectorless is this deliberate step-by-step navigation. And that directly impacts context usage. Vector RAG often pulls in all this noisy kind of related stuff, whereas the vectorless approach is just surgical. It selects only the pages that are logically required to answer your question.
So after all that, what's the final verdict? Is it time to just throw out all our vector databases? Well, not exactly. It's not about one being definitively better. It's about understanding you've got the right tool for the right job.
Let's be real, this method isn't a magic bullet. It really depends on having a well-structured document to work with. I mean, if there are no clear headings or sections, it's going to struggle. That step-by-step reasoning process can also be a bit slower than a simple vector search, and it's really built for deep dives into single, complex documents, not for searching across thousands of totally disconnected files.
So where does this method become an absolute game changer? It's when you're working with a long, dense, and well-structured document where context is everything. Think of things like legal contracts, super detailed technical manuals, or academic research papers. In those situations, this reasoning-based approach is incredibly powerful and precise. You know, this whole shift from mathematical searching to logical reasoning really feels like a major step forward in how AI is evolving. And it brings us to a final, really fascinating question to think about. As AI gets better and better at actually thinking and reasoning like we do, will the entire concept of searching for an answer just become obsolete? Something to chew on. Thanks for watching.